is prepared for Standard 9 Chemistry. The chapter is redox reactions and rate of chemical reactions, and the topic is balancing of chemical equations. We know there are many changes happening around us. These include both physical change and chemical changes, which are as shown below. Chemical changes result in the formation of new compounds. Here we discuss only about chemical changes. Given below is a table showing the mass of reactants and products when hydrogen combined with the chlorine to form hydrogen chloride in two situations. In first case, 2 gram of hydrogen combined with 71 gram of chlorine to give 73 gram of hydrogen chloride. In second case, 4 gram of hydrogen combined with 142 gram of chlorine to give 146 gram of hydrogen chloride. Now write down the total mass of reactants and also the total mass of products in the above experiment. In situation 1, total mass of reactants is equal to total mass of products, that is 73 gram. And in situation 2, the total mass of reactants is equal to total mass of products, that is 146 gram. Now consider the case where hydrogen is combining with oxygen to give water in two situations. In situation 1, 2 gram of hydrogen combined with 16 gram of oxygen to give 18 gram of water. In second situation, 4 gram of hydrogen combined with 32 gram of oxygen to give 36 gram of water. Write down the total mass of reactants and the total mass of products in the above experiment. In situation 1, the mass of reactants is equal to mass of products, that is 18 gram. And in situation 2, mass of reactants is equal to mass of products, that is 36 gram. Now, what is the relation between the total mass of reactants and the total mass of products? Total mass of reactants and products remain the same. In a chemical reaction, mass is neither created nor destroyed. And this is a law of conservation of mass. This law was proposed by the scientist Antoine Lavoisier. That is, the total mass of reactants will be equal to total mass of products. If so, total number of atoms of each element in the reactant side and that in the product side in a chemical reaction are equal. Now, let's see what is balancing of chemical equation. Let's start with a reaction. A piece of magnesium is burned in air. What do you observe? It burns with a bright light and give a white powder. What is that white powder? The white powder is magnesium oxide. How can you represent this chemical reaction? Magnesium plus oxygen giving magnesium oxide. And if we use simple and chemical formula, it can be written as Mg plus O2 giving MgO. And this is a chemical equation. Which are the reactants here? Magnesium and oxygen. And the product is magnesium oxide. Now, note down the number of atoms in the reactant side and the number of atoms in the product side. Is the number of atoms of each element equal on both sides? No. The number of which atom is not equal on both sides? Oxygen. Then how many product molecules are needed to equalize the number of oxygen atoms on both sides? It is 2. How will you represent 2 molecules of magnesium oxide? By putting 2 before MgO. Now, is the number of magnesium atoms equal on both sides? No. How many magnesium atoms are needed in the reactant side to equalize the number of magnesium atoms on both sides? It is 2. Then how can you rewrite the above equation? 2 Mg plus O2 giving 2 MgO. Is the total number of atoms of each element in the molecule present in the reactant side and that in the product side equal in this equation? Yes. Now won't the mass on both sides be the same? Yes. In this manner, equalizing the number of atoms of each element in molecules in the reactant side and that in the product side is known as balancing of equation. Now, let's look at another example. Zn plus HCl giving ZnCl2 plus H2. Look at this table. How many zinc atoms are there in the reactant side and in the product side? It is 1. Which are the atoms showing at different in the number? That is at hydrogen and chlorine. In order to make them equal on both sides, how many molecules of HCl should be taken as reactant? It is 2. So, now the reaction can be rewritten as Zn plus 2HCl giving ZnCl2 plus H2. Let's balance the chemical equation. H2 plus O2 giving H2O. When the number of oxygen atom in the product side is made 2, this equation can be rewritten as H2 plus O2 giving 2H2O. And by looking at the table, we can say that the number of hydrogen is not same at the reactant side and the product side. So in order to make the number of hydrogen atom in the reactant side 4, shouldn't we take 2 hydrogen molecules? Yes. So 2H2 plus O2 giving 2H2O. Now let's balance the equation Al plus O2 giving Al2O3. If we make the number of aluminium atom 2, the equation can be rewritten as 2Al plus O2 giving Al2O3. Is the number of oxygen atoms on either side equal? How can we make it equal? The number of oxygen atoms in the reactant side is 2 and the number of oxygen atoms in the product side is 3. So in order to make them equal on both sides, the number of oxygen atoms should be increased to 6. Then how many oxygen molecules are needed in the reactant side? It is 3. So the reaction can be written as 2Al plus 3O2 giving 2Al2O3. Then make the number of aluminium atoms equal on both sides. So, when we conclude, the process of making number of reactants and products equal on both the sides of a chemical reaction is called balancing of chemical equation. A chemical equation is balanced on the basis of law of conservation of mass. The law of conservation of mass states that in a chemical reaction, total mass of reactants and products remain the same.